When a shooting victim arrives on the autopsy table, they can no longer speak. To determine exactly what happened, a forensic pathologist has to reverse engineer the events of the crime by reading the physical trauma left behind on the body. The first medico-legal objective is straightforward: confirm that the damage was actually caused by a firearm, ruling out a puncture wound or blunt force trauma. That investigation begins beneath the skin. Pathologists use blunt medical probes and extensive imaging to map the exact internal tract the bullet carved through the tissue. This X-ray shows a classic pattern known as a snowstorm appearance. When a non-jacketed or sunny-jacketed bullet strikes bone, it violently fragments, scattering small, bright pieces of lead across the internal cavities. Finding these fragments and mapping the internal tissue damage is the necessary first step to calculating the trajectory and pinpointing exactly where the shooter was standing. Once the internal tract is mapped, the analysis shifts outward to the skin's surface, where investigators have to definitively distinguish the entry wound from the exit wound. This schematic shows how an entry wound forms. As the bullet hits, it stretches the skin inward, creating a temporary tube. The bullet then perforates the tip of that tube, aggressively scraping the edges of the skin as it pushes through. That scraped edge quickly dries out, forming a dark, distinct ring called an abrasion collar. If this collar is perfectly circular, like we see in this photograph, it proves the bullet struck the body at a perpendicular 90-degree angle. But if the bullet strikes at an angle, the mechanics change. An oblique impact creates an oval-shaped collar, leaving a noticeably wider scraped margin on the side where the bullet first made contact. By analyzing the exact geometry of that tiny ring of scraped skin, pathologists can mathematically prove the bullet's angle of attack at the precise fraction of a second it broke the surface. To find the range of the shooter, pathologists have to look past the physical tear in the skin and examine the microscopic residue left behind by the weapon's expanding gases. When a gun is fired from 0 to 6 inches away, what we call contact or near contact range, the rapidly expanding gases get forced directly into the wound, trapping high pressure between the skin and the underlying bone. This trapped pressure causes severe trauma. It elevates and splits the skin into a violent star shape, leaving a physical imprint of the hot muzzle burned right into the tissue. This diagram shows close-range residue patterns. Shots from 6 to 12 inches leave blackening, a dark soot coating the wound. At an intermediate range of 12 to 18 inches, we find tattooing. These are unburnt gunpowder grains physically embedded into the skin. Identifying these specific residue zones gives forensic investigators the hard physical evidence they need to establish the exact distance of the barrel, either validating or completely disproving witness testimony. But real-world crime scenes are chaotic. Pathologists constantly have to account for intermediate ballistics. What happens when a bullet doesn't travel cleanly through open air? If a bullet passes through a window or a wooden door before hitting the victim, it shatters that material. Those tiny glass or wood fragments strike the victim and create pseudo-tattooing, closely mimicking the marks of a close-range shot, even if the shooter was far away. Another common environmental variable is a ricochet, where the bullet strikes a hard surface, like concrete or steel, drastically altering its flight path. A ricochet causes the bullet to deform and tumble end over end through the air. When it finally strikes the victim, it creates a massive, bizarrely shaped entry wound that often lacks a clean abrasion collar entirely. Pathologists have to identify and rule out these environmental interferences. Only then can they lock in a perfectly accurate geometric reconstruction of the crime scene. The final step in reverse engineering a shooting is connecting the terminal ballistics, the specific wound patterns on the body, back to the mechanical design of the weapon. This diagram shows the cross-section of a modern shotgun shell. Unlike a rifle, a smoothbore shotgun fires a cluster of individual pellets packed above plastic wads, resulting in massive, widely distributed tissue damage rather than a single clean puncture. To keep those pellets clustered together over long distances, shotgun barrels often use a choke, a deliberate narrowing of the barrel's internal diameter near the muzzle. Rifled weapons operate on a completely different mechanical principle. Inside the barrel, helical grooves grip the bullet, forcing it to spin rapidly as it accelerates. That gyroscopic spin prevents wobbling, guaranteeing a straight trajectory, deep penetration, and a tight, predictable wound channel. Matching the internal tissue damage and the entry wound profile to these specific mechanics firmly links the victim's injuries back to the exact class of murder weapon. The ultimate legal objective of the forensic autopsy is to categorize the death into one of 4 classifications: natural, accidental, suicidal, or homicidal. Pathologists arrive at that verdict by combining every piece of physical evidence: internal trajectory, specific residue range, and the mechanical signature of the firearm. A victim may not be able to speak, but the unalterable physics of wound ballistics provides a permanent scientific testimony